So, hello everyone and welcome to this second lecture on Ethereum. So, in this particular lecture, we will be discussing about some more complex transactions on the Ethereum network, and we will be seeing how we can use the Go Ethereum client and the account that we created to transfer some amounts of Ether from one account to another, and we will be seeing how we can monitor those transactions. So, the keywords for this lecture are Ethereum transactions, we will be learning about gas and also faucet, which is the way of obtaining some ethers for the test networks. So, in the last lecture we saw that we can use the Go Ethereum client to do some queries over the Ethereum network by just sending post requests using RPC over HTTP API, which is exposed by the Go Ethereum client. So, these particular queries were just about reading the Ethereum ledger and not really changing any data or writing anything back to the ledger. So, to write something to Ethereum ledger or to commit some new transactions to the Ethereum ledger, we need to invoke and basically execute Ethereum transactions, which are nothing but cryptographically signed instructions from already registered accounts. Okay. So, accounts are basically a key pair, public key and a private key. So, when you want to do a transaction in the Ethereum network, then you need to use your private key to sign a transaction and then you need to send it over the network. So, an account will initiate a transaction to update the state of the Ethereum network, and the simplest transaction that you can think of is just transferring some amount of Ether from one account to another. So, to execute a transaction you need particularly two things. One is access to an account, which means access to the private key of the account so that you can sign the transaction, and then the second thing is gas. So, gas is basically a fee that you need to pay to execute some transaction over the Ethereum network. So, each network, be it mainnet or test network, you would need to spend some amount of gas to do some transactions. So, what is gas? So, each Ethereum transaction will require some computational resources to execute. Basically, for executing smart contracts, some logic is being executed by the miners and the verifiers. Same thing for transferring balance from one network to another network. There also your transaction need to be validated by the miners and also the other participants which are validating the blocks. So, as a result, each transaction needs to have some kind of a fee, and this fee is basically gas, and gas is basically paid in amounts of ethers. So, in Ethereum you need to spend some quantity of cryptocurrency to execute any kind of transaction. So, for getting some gas in the main network, you would need to somehow get some Ethereum or ethers, which you can buy from different cryptocurrency exchanges in exchange of real currency, in for example, in against rupees. So, you can pay an Ethereum basically a cryptocurrency exchange some amount of rupees, and in exchange of that exchange will provide you some amount of Ether. So, you can get cryptocurrencies for the main network in that way, or you can participate as a miner, and if you can mine some blocks or if you can take part in a mining pool which is successful in mining blocks, then you will be getting some amount of Ether yourself. But usually Ethereum is expensive, and for doing transactions we would be for testing transactions we would be using the Ethereum test networks, specifically the GoLD network in this case. Now, participating in a test network is no different technically than participating in a main network. The only difference is that in the test networks you can get some ethers easily without spending any money or resources. So, for Ring-B, Ropsten and GoLD, all these three popular test networks, they have a tool called faucet using which you can get some ethers, and you can use those ethers to do transactions and basically pay the gas fees. Okay. So, these are the different URLs to the faucets of Goerli test networks and Ringby test networks, but they usually have a mechanism to limit the amount of ethers that each user can get, because of course, if these faucets are not restricted, then some malicious users can go and get as many ethers as they want, and then they might do many transactions and kind of DDoS or DOS the network, basically launch a denial of service attack on this Ethereum network. So, to get Goerli test network ethers, you can use the faucet of the Goerli testnet. This is similar to Ringby test networks also. So, these faucets are protected by a mechanism in which you need to use your social media accounts, and you need to post something in your social media accounts, and then only you will be able to get the ethers for these test networks. So, in this Goerli faucet, what you need to do is you can post a new tweet which will contain your public key of the Ethereum account that you are using, and then using this tweet you would need to copy the URL for this tweet and then paste it in the Goerli testnet portal. So, they have this portal for the faucet. If you paste the URL of the tweet, it will give you 3 options: 6 ethers for 1 day, 15 ethers for 3 days, or 37.5 ethers for 9 days. So, for one account, if you select any of these options, for example 15 ethers for 3 days, then you won't be able to use your social media account or your Ethereum account's address for obtaining ethers for this Goerli test network for 3 more days. Okay. So, for getting more ethers, what you would need to do then, you would need to create a new social media account and use that. So, in this way the flow of ethers in this test network is kind of restricted. So, once you have some ethers in your test network accounts, you can get started using that amount of ethers to do some transactions. But before you can do transactions, what you need to do is you need to unlock your account. To create a new account for Goerli testnet, you need to have this option specified, which is -- Goerli, and then you can use the password which you are setting while creating the account. You can save that password into a text file and then use that password to connect to the Goerli test network in an unlocked account mode. How to do that? So, that is done by passing these options unlock insecure, allow insecure unlock, and unlock then account's address, and then passing the path to the password file. So, we will show you how you can create a new account in the Goerli test network, or how you can use an existing account and move it to the Goerli test network, and then how you can connect to the test network by unlocking this particular account. So, if we see get space account space list, then this is basically listing all the accounts which are created for the Ethereum main network, because here you see the option -- Goerli is not specified. Now, if we pass this option Goerli, then do account list, then we would see that there are actually no accounts listed under the Goerli test network. So, we have 2 options. The first is simple. So, we can just do get space -- Goerli, then account new, and it will ask us for a password. We are setting the password as 123. Then this is simply creating a new account for you in the Goerli test network. Now, if we do get space -FN Goldly, then account list, we would see that there is only one account, the new account that is that we just created, but we already had an account in the Ethereum main network. As you can see here, the account 0 in the Goerli network and the account 0 in the Ethereum network are different. So, what if we wanted to use the account which we already created in the Ethereum main network in the Goerli network? So, we can do that by simply copying this file in the key store from the Ethereum directory to the Ethereum / Goerli / key store directory like this. So, you can copy the name of the account in the main network, and then you can use this command cp and then pass the path to this directory Ethereum / key store / the name of the account, and then simply copy it to Ethereum / Goerli / key store. Now, if you do get space -FN Goerli space account space list, then we can see that the two accounts are listed here. So, now we have these two accounts as well in the Goerli test network. So, if we want to use this to do some transactions, what we would need to do is basically we need to save this password 123 which we had set while creating this account into a file called any you can name it anything. We are just naming it pwd.txt. So, you can simply do echo space then in quotes your password, then this symbol greater than symbol, which will be redirecting this output of echo which is the password to this file named pwd.txt. Now, we can use this command cat space pwd.txt to see and verify that the contents of this password file is proper. So, we can start this test network or Go Ethereum client and connect to this test network in this sync mode light and HTTP enabled, and then we can pass this option allow insecure unlock and also -FN unlock then space the public key of the account which we want to unlock, and then add the option to specify the password file. So, -FN password space name of the file where the password is saved. So, if we hit enter, we can see that the output is same, but here we have one extra print statement, that is unlock account and then address. So, from the third last line you can see unlock account address. So, we will keep that terminal running, and then we will be using that Ethereum client to do some transactions. So, once we have this Ethereum client, Go Ethereum client running while the account is unlocked, we can use that to send some transactions by doing RPC over HTTP API calls. So, we would be doing a simple transaction to send some amount of ether from one account to another account. So, to do that we will be using ETH_send transaction. So, this type of transaction, as you can see here, that this is also similar to get balance, but it is a post request and it takes different parameters. So, we need to specify from, to and also value. So, the from is basically the address the transaction is sent from. So, basically if you are sending some ether from account A to account B, then from would be account A and to would be account B, and value would be the quantity of ether that we want to send. Okay. So, you can actually use this ETH send transaction to execute more kinds of transactions. Basically, apart from sending Ethereum from one network to another, you can use this to deploy smart contracts also, but we will be just sticking to this simple case of sending transactions or sending Ethereum from one account to another. So, to prepare a send ETH or send transaction, ETH underscore send transaction, to prepare this ETH underscore send transaction, you need a payload like this. It is very similar to the get balance payload, but the method name is ETH underscore send transaction and these parameters are different. So, the from is from address to, and then this value is basically the amount of ether you want to send in hexadecimal format. Okay. So, this is basically 0.1 ether. So, this is 0.1 into 10 to the power 18 way, which is converted into hexadecimal, and this is the value in the hexadecimal that you need to pass to do the transaction. Then simply we need to submit this transaction as a post request, very similar to the step we did before for querying the balances. So, we would be using this curl command to send a post request, and it will give us an output which will contain the hash of the transaction. Okay. So, the hash of the transaction is something like this, it is a hexadecimal string, and we can use this hash to actually monitor the status of this transaction from a portal. So, each Ethereum network usually runs this Etherscan portal, or the popular networks run this Etherscan portal. So, we have one Etherscan portal for the main network as well as for these popular test networks Ropsten, Ringbee and Goerli. So, if you open Goerli's Etherscan portal, we will be able to monitor these transactions there. And then finally, if you want to also query the status of this transaction from the Go Ethereum client itself, you can also do that using a different kind of query, which is ETH underscore get transaction by hash. So, it will take this parameter of the hexadecimal string, which is a transaction hash, and then it will provide you some information which is will show you the status of this transaction. If that is mined, it will show you in which block it had been mined, etc., and many other details. So, before actually sending the Ethereum from the two networks, let us just first query the balances. We can see that in this account starting with 0xD48, we have this particular balance. So, we can also convert it into decimal to check what it looks like in way unit. So, as you can see, it is basically 0.1 ether. Now, we can we have to use another account where we will be sending this amount. So, we can query the other account starting with 0x5f, and we can see that the balance of this account is actually 0. So, to send some Ethereum from this from this first account to the second account, we are sending this post request with the method ETH underscore send transaction, and you can see the from and the two account addresses, and this value is actually 0x238f etc. in hexadecimal. It will convert to 0.1 ETH if you convert it to decimal. Okay. So, from this output you can see that there is a result. This result is actually a hash of this transaction, okay, submitted transaction. So, we can use this hash to monitor the status. So, we can go to Goerli's Etherscan portal, which is goerli.etherscan.io, and we can paste this transaction hash in this particular portal, and if we hit search, then you will see that it is currently saying pending, and it has some submitted time. So, how much time ago it was submitted, and after a few seconds you will see that when it is included in a block, it will say that it is successful. Yes, now you can see that it is successful. So, if you click on this block number, you will also find more details about in which block it was mined. Now we can also use this post request with ETH underscore get transaction by hash and paste the hash of the transaction as parameters to get the transaction details from this Go Ethereum client. So here also you can see that here also you can see that it has printed their result, which contains the block hash as well as the block number and some other informations like the transaction index, which is the index of this transaction in that particular block, etc. So from the transaction hash, what you can do is you can also query the block in which that transaction was committed. So to query blocks, there is another query method, which is ETH underscore get block by number. So you can pass the block number and then you can query information about that block. Okay. So here the parameter is just a single one, which is block number, but this input also you need to provide in hexadecimal. So if your block number is something like 5000 in decimal, you need to convert that into hexadecimal and then pass it as a parameter. Then to execute that request or do that query, you can use curl, and this curl command will give you the output, which will contain many details about this particular block. Okay. So it will say what was the block number and what was the difficulty. Then it will also list all the transactions that were in the block. It will specify what was the miner and nonce, etc., etc. So from the transaction hash, we can go to Etherscan, and from there we can get the block number. So what you can do is you can use some tool to convert this block number from decimal to hexadecimal format, and then copy that hexadecimal representation of the block number and use that in your query to get the block by number. So you can just do this curl request, and in the parameter you can pass the block number as an hexadecimal string. I mean the one we just converted, you can paste it there, and if you hit enter, then you will see that you get a very long output which has many details about this particular block. So from this output of this block, we can actually copy it and then we can format it properly as a JSON, and then we can find out what details are there. So you can use any good text editor. So I am using VS Code here. So you can paste this output of this block and then format it as JSON and do some proper indentation. So now after re-indenting this entire thing, you can easily see what contents are there in this particular file. So we can see that it lists several information such as difficulty, then gas limit, then gas used, hash, and then also the nonce. Okay. And this is the block number which we also use to query it. And then after that, it is basically listing all the transactions from line 23 onwards. You can see that there is a list of transactions, and each transaction then also has block hash, block number, to, from, gas, nonce, etc. So, we saw how to actually send a transaction and use send transaction to transfer some amounts of ether from one network to another network. Then how to query the transaction hash and status of the transaction using the transaction hash, and also the block in which that transaction was committed, and many details about those blocks. So, similar to these kind of queries and different types of transactions, so there are various RPC methods that you can use. So, this is a list of some of them. You can go to this URL and find out the entire list of the possible RPC over HTTP methods that you can use to query and transact over the Ethereum network. So, in conclusion, in this particular lecture we saw how Ethereum transactions work and why each transaction needs some gas, and we saw how we can use the faucets for obtaining ethers for testnets, and then how we can unlock our own account in the Go Ethereum client and use the RPC over HTTP API to do some actual transactions. We saw how we can send send some amount of ether and also monitor that. So, thank you, and in the next lecture we will see how actually we can write some programs using an SDK on top of this Go Ethereum client and programmatically execute transaction towards building decentralized applications or dApps. Thank you.